apologize. The technology for this course is trying to be the bane of my existence. So we talked about for 1b that if my GCF is 3x squared, that if we looked at it as a multiplication, we would get 3 plus x, and this would be my factorization. And then the second way we can look at it is division, where if I know that the GCF is 3x squared, we can divide each one of the factors in the polynomial by that GCF, and that will give me what I need to multiply by. So we know that 9 divided by 3 is 3. And remember, if we have x squared over x squared, you can look at it as something over itself just makes 1. Or if you use the quotient rule for the exponents, it would be x to the 2 minus 2 is x to the 0, which is 1. Then if I divide 3x cubed by 3x squared, the 3 over itself will make 1. And then we have x to the third over x to the second. So we would use the quotient rule and say that's x to the 3 minus 2 is x to the first. And you see we end up with the same factorization. So you can look at it either way, it doesn't make any difference. For the second problem, now we have 3 different terms, but we still, if we want to find a GCF, attack it the same way. First, we're going to look at the numerical coefficients. You don't really have to worry about differences in signs. If I have 12, 6, and 3, and I want the GCF, first thing I notice is these are multiples of each other. 12 is divisible by 6 and by 3, and 6 is divisible by 3. If they're multiples of each other, the GCF is just going to be the smallest number. This time when we look at the variable terms, we have 2 different variables. First, I have an x variable. I have x cubed, x squared, and I have an x. Now remember, when it comes to variable terms with exponents, we're always going to choose the smallest. So x to the first power is the smallest. This time we have a second variable y. We have y to the first, y cubed, and another y to the first. So between y to the first and y to the third, the first is the smallest. So the overall GCF, we would multiply the 3 times the x times the y, which gives me 3xy. So then when we go to 2b, and we want to actually factor this polynomial, then we're going to write that GCF out front. And if you look at it as multiplication, we would ask ourselves first, what do I need to multiply by 3 to get negative 12? And that would be negative 4. If I have x to the first and I need x to the third, I would have to multiply by x to the second, because x to the first times x to the second means I would add the exponents, and that would give me x to the third. Then the GCF has y to the first power, and I need y to the first power, so we don't need any more y's. Then we're going to move to the second term. We need to know 3 times what will give me 6, and that is a 2. If I have x to the first and I need x to the second, then I need one more x to the first. And if I have y to the first and I need y to the third, I need 2 more y's. Then for the last term, you notice my GCF is 3xy, and what I need to have is negative 3xy. So the only difference between what I have and what I need is a negative. So I would need to multiply that 3xy times a negative 1. So this is my factorization. Now I'd like for you to also notice that the first time I took out a positive 3xy, it is also just as correct if you had decided to take out a negative 3xy. The only difference is all of the signs of the terms inside the parentheses would then change, because if I have negative 3 and I want negative 12, I would need to multiply times positive 4x squared. And then if I have negative 3 and I want positive 6, I would need to multiply by negative 2. And if I have negative 3xy and I need negative 3xy, I would just need to multiply by 1. So either one of those factorizations is just as correct. Okay, for the next problem, notice that I don't have it divided out into the two different parts. So usually we won't ask you when we want you to factor to tell us the GCF first and then to show the factorization. So this is kind of how the problems will look. So if we use the same process, if I look at the numerical coefficients 4 and 9, those are not multiples of each other. 9 is not divisible by 4. And they also don't have any common factors other than 1. And if we look at the variable terms, the first one has an x, but the second one does not. So there's not a common x variable to both terms. So the only thing that these two share is a y to the first. So my GCF in this case is just y to the first. So we're going to take that to the front. And then if I have y to the first and I want 4xy, I'm going to need a 4x. Then we have a minus sign. And if I have y and I need 9y, then I'm going to need a 9. And I didn't show this in the last problem, but once again, just like in the very first problem I showed you, if you want to check if you distribute what the factorization is that you got, y times 4x gives me 4xy, and y times negative 9 is negative 9y. So you should also always be able to multiply your factorization back out and get the original. Okay? Now, number 4 may look a little intimidating, but if you notice something about this, then it's not as bad as it seems. Remember that we're talking about finding common factors? Well, if you look at my terms this way, you see that each one of these two terms has this common factor of y minus 5. So it's a little harder to think about because it's an expression, but it works the same way as if both of those terms had a common y. What's common is the expression y minus 5. So I'm going to write that out front. And then I tend to look at this as when I take that common factor out, what goes in the parenthesis is what I call the leftovers. So if I took the y minus 5 from that first term, what's left over is the 4x. Then we have a minus sign. And if I take the y minus 5 from the second term, my leftover is a 9. So this is my factorization. Very similar for number 5. I also have this common factor of y minus 5. So I'm going to copy that down out front. And then if I were to take that y minus 5 from the first term, I'd be left with 4x. And then we have a plus sign. What's a little more tricky about this one is if I take the y minus 5 from the second term, it looks like there's nothing left. But remember, when we're looking at multiplication with parentheses, if there's nothing in front of there, there's always that implied 1. So if I take the y minus 5 from the second term, what I'm left with in this case is 1. And looks like when I did that, I wrote over it and lost my sign. Sorry, so we would get, if we take the y minus 5, then we end up with plus 1, and this is my factorization. So what this really leads to is this next topic that we're going to look at, which is called factor by grouping. And when we would want to do this is, in some cases, you're going to find that there may not be a GCF for all of the terms in a given polynomial. So when I'd be looking to do factor by grouping is if the problem has 4 terms and there is no GCF for all 4 of the terms, then we'll look at factor by grouping. So the strategy is listed next. Let's work through example 1 using the strategy. First it says to group the first 2 terms. So what that means is I'm going to group the first 2 and then we're going to group the last 2 terms. So what we want to do is factor a GCF from the first group, which is xy minus 9y. So we don't look at the 3x minus 27 at all for this part. Just look at the first 2 terms and look to see what they have in common. So xy minus 9y, the only thing those have in common is a y to the first. So that's what I'm going to take out. And then this works exactly like what we've been doing. If I have y and I want xy, I need to multiply by x. We have a minus sign. If I have y and I want 9y, I need a 9. Then we have a plus sign. And then our last 2 terms, we have 3x minus 27. And we want to know what the GCF of just that pair is. So they don't each have the variable x. So any GCF is just going to be a numerical coefficient. And between 3 and 27, we know that those are multiples of each other. So the smaller number is going to be my GCF. And then to get 3x, I would need to multiply by x. We have a minus sign. And 3 times 9 is 27. So if you look at what we've ended up with here, this has to happen for factor by grouping to work. And this is why we looked at the problem that we just did on the other page, because at this point we have to take the common factor that is x minus 9 and bring that to the front, and then if I were to take that out, my leftover is a y, then a plus, and a 3. So this is my completed factorization. For number 2, we're going to do the same thing. I'm going to group the first 2 terms and the second 2 terms. If I look at just the first 2 terms, the only thing that those 2 terms have in common is that they each have an x variable. So I'm going to factor out that common factor of x, and that's going to leave me with c plus 6. Now on this one, you notice the difference are the signs. I have a negative 3c minus 18. Most of the time when we do these, if the 2 numbers or expressions in that second grouping are both negative, we're going to end up factoring out a negative. The 3c and the negative 18, they don't share any common variables, so the only thing they have in common is a factor of 3. So if I factor out a negative 3, that's going to leave me with c. Be really careful with this next sign. I've got negative 3 and I want negative 18. So this is going to be a plus 6. Another way to keep that straight is, remember we said for grouping to work that this has to happen. So if we got c minus 6 in that second parenthesis, that would probably be a hint that something was up. Then again, I take my common factor, which this time is c plus 6, and bring that to the front. And then if I were to remove those, I'd be left with x minus 3. So that would be my final factorization. Alright, so with number 3, again we got 4 terms. There isn't a single common factor to all 4 of the terms, so we're going to look at it the same way. We're going to group the first 2 and the second 2. This time I have 6a squared minus 15a. So we're actually going to have a common number and a common variable. 6 and 15 aren't multiples, but they are both divisible by the number 3. And then I have an a to the second and an a to the first. So we always take the smallest. And then if I have 3a and I need 6a squared, then I need to multiply by 2 to get the 6. And we need one more a. And notice if I multiply that, it makes 6a squared. Minus, if I have 3a and I need 15a, then I need to multiply by a 5. So the second 2 terms, the 2 and the 5, they're not multiples and they have no numbers other than 1 in common. So the only common factor is that common variable of x. And you notice that negative 2ax, since that's negative, I'm going to pull a negative out here, So if I have negative x and I want negative 2ax, then I need 2a. And again, be careful with the signs. If I have negative x and I want positive 5x, then I'm going to need to multiply by a negative 5. And again, notice you can kind of self-check yourself because we need to end up having that same common factor so that I can take that 2a minus 5 to the front. And then that's going to leave me with 3a minus x. And that is my final factorization. Now the next one is very similar but slightly different. You see when I group the second two, it's missing that common x this time. So the first two terms, 6a squared minus 15a, the same thing that I got in the last problem is going to be here. My GCF is still 3a, and that's still going to leave me 2a minus 5. When I get to those second two terms, 2 and 5 aren't multiples. They don't have any common factors other than 1, and they don't share a common variable. So what that means in this case is that the only thing that's common to that 2a minus 5 is a 1. So we're actually going to write that out front. 1 times the 2a minus 5. So by doing that, it looks the same as the ones we've been doing, where I can take that common factor of 2a minus 5, and then if that's gone, what I'm left with is a 3a plus 1. And that's my final factorization. Alright, last one, and we won't deal with this a whole lot. In this last one, I just wanted to point out that each one of these, we have grouped the first two terms and the second two terms. Well, that may not always work out. If I did that here, if you look at those first two terms, 4x cubed minus 15, then the 4 and the 15 aren't multiples. They don't share an x variable. So there would be nothing but a 1 that they have in common to be able to factor out. And then for the second two terms, 20 and 3 aren't multiples. They don't have common factors. The only thing that those two terms have in common is a factor of x to the first, and that would leave me with 20x minus 3. So you notice what happened here. I said in order for factor by grouping to work, we had to end up with that common factor, and we don't here. So the only thing that we could do at that point is to try and group them differently. So let's say instead of doing the first two and the last two, let's say that we rewrite this as 4x to the third plus 20x squared minus 15 minus 3x. And let's try to group the first two and last two again and see what happens. Now the first two terms, the 4 and the 20, have a common factor of 4, and we can take the smallest exponent. And this is going to leave me with x plus 5. And then for the second two, I'm going to take that negative factor out as we discussed before. These have a common factor of 3. So negative 3, if I want negative 15, I'd need positive 5. And negative 3 to get negative 3x, I would need plus x. Now remember we've talked about in earlier times x plus 5 and 5 plus x. Addition is commutative, so those are exactly the same thing. So this time we did end up having that common factor. So I'm going to bring that common factor to the front. And then that will leave me with 4x squared minus 3. And this is my final factorization.